There's a feeling of standing at the bottom of a massive mountain. A huge, overwhelming obstacle in your path seems a bit familiar.
It's just impossible. There's so much to learn.
I've got so many books to revise from. I just don't know where to start.
How do they expect us to cope?
I just feel like running away.
Your task seems so enormous, you can't see how you can overcome it. So how do you tackle it? One step at a time. By planning out your route and knowing what you will be doing at every point on the way, even if your goal isn't in sight, you know you're getting there. A major part of that is organising your revision, which is where we come in.
First, we shall look at some of the basics in a range of topics. Then, use that to work through exam questions with an examiner. An examiner sees where most people go wrong. We want to know how to avoid those pitfalls. And it would also be a help to have some tips on exam technique.
Have you ever seen an examiner? Has anyone? Who are these people? Fuddy-duddy old professors at some far-off university, head in the clouds, dreaming up impossible questions designed to trip you up at every turn? Will these people be willing to help? Here is a maths examiner.
Hello.
This is Brian Speed. Brian, what qualifies you to assess all these students?
Well, actually, I teach maths in a comprehensive school, so I have a pretty good idea of what they can do.
And what's the point of the maths exam?
I'm simply trying to find out what maths the students actually know. I'm not trying to catch anybody out, simply giving opportunities for them to demonstrate what they have learned.
What do you have trouble with in maths?
Inverse ratios.
Special numbers. I mean, a number's just a number, isn't it?
When it's 2 decimal places or 3 significant figures.
Percentages. Why do we keep on doing it when we can use our calculator?
Well, I can handle the maths when it's just numbers, but when they mix it up with all the words in the questions, I get lost.
Right, we have our examiner here, and he actually says he wants you to do well in your exams, and he's willing to help you in any way he can. And we have a group of students ready to interrogate him, so let's make the most of it. On this topic of numbers, where do you want to start?
Percentages. We do it every year at school. Why is it so important?
It's a significant part of everyday life. Machines, that's calculators, computers, they can do the long calculations, but we still need to know what to do and when.
Okay, we've got some very interesting information on percentages. Let's take a look.
1% is the same as 1/100th, which is the same as 0.01. So 2% is 0.02, and 15% is the same as 0.15. To change a fraction to a percentage, simply multiply it by 100. A test score of 18 out of 20 would be 18 divided by 20 times 100, or 18 times 100 divided by 20, which is 90%. An example of the use of percentages might be in calculating VAT. If VAT is charged at 15%, then an article priced at £60 in a wholesale market will cost a customer £60 plus VAT at 15%. Which is £60 plus 15% of £60. That is the same as £60 plus 15 over 100 times £60, which equals £69.
Right, now we know what we're talking about. Let's try out an example. Now, this is a fairly typical percentage question.
Zoologists have found that a baby octopus increases its weight by 5% every day. If an octopus weighs 150 kilograms, how much will it weigh in 3 days?
Right, Brian, work through this and show us exactly what you're looking for. We need a student first. So do you want to do it, Keith?
The octopus grows by 5% of 150 in each day. So after 3 days, it will be 7.5 times 3 kilograms heavier.
Hang on a minute. After the first day, it weighed 157.5 kilograms, so 5% of that's bound to be more than 5% of the first 150 kilograms. This is what's known as compound interest, when you have to take into account the 5% rise each day.
After the first day, the octopus weighs 157.5 kilograms. Times that by 105%, and you get 165.375 kilograms. times that by 105%, and you get 173.64375 kilograms.
Good, but you should only give your answer to one decimal place.
173.6 kilograms.
That's right.
So obviously, Brian, a lot of people have difficulty with percentages. Can you please simplify it for us?
I'll try. A percentage is very simply a number out of 100. So like 25%, 25 out of 100, or 25 hundredths.
Right, that's good. What about the difference between compound interest and simple interest?
Well, simple interest is when you have the same amount added on each time, exactly the same amount. Compound interest is when your percentage builds up, so you gradually get more and more of it.
All right, if you've got loads of dosh, builds up quicker.
That's right. So if you have an examination question, for example, you need to know whether it's simple interest or compound interest, and then get it right.
Right, still on this topic, what else do you find difficult about numbers?
Well, I don't have too much trouble with the straightforward maths. It's just if we get a paragraph of writing, I have difficulty in sorting out what numbers are supposed to work with.
Well, in the real world, numbers don't just present themselves at you. You probably have no difficulty working with words and numbers in, shall we say, buying your clothes.
Right, have a look at this.
A builder knows that his gang of 18 workers can build 12 houses in a month. He has a contract to build 16 houses in one particular month. How many men will he need in his gang? First, read the question carefully so you understand the problem. Approach it by breaking it down into simple stages. 18 men will build 12 houses in 1 month. So, how many men will it take to build one house? 18 divided by 12 on the calculator, that's 1.5. So, it takes 1.5 men to build one house. And for the purpose of calculating the answer, we have to talk about 1.5 men, even if in real life you'd probably use 2 instead of 1.5 men to build a house. To find out how many men it takes to build 16 houses, multiply by 16. That is, 16 times 1.5, which equals 24. It will take 24 men to build 16 houses in 1 month. All the number and arithmetic questions in the exam will take the form of problems like this. Remember the stages that we've just gone through. Read the question. Think about the arithmetic involved. Do it correctly. Show each step of your method so you can get marks for that, even if your answer is wrong.
Do any of you work in a burger bar on a Saturday?
Yeah, I do.
Oh, right, well, you'll have no difficulty at all with this question.
Mary works in a burger bar. She earns £2.60 per hour on weekdays and time and a half on Saturdays. How much will she earn for 4 3/4 hours on a Saturday?
Tracy's going to do the question. Brian, explain what you're looking for.
So if I work out how much she earns in 1 hour on a Saturday, I can calculate that from that how much she earns in 4 3/4 hours.
Yeah.
Right, so she earns £2.60 multiplied by 1.5 per hour, and multiply that by 4 3/4 to see how much she gets in all. And 4 3/4 is the same as 4.75, and 1.5 is the same as 1.5.
Yeah. You know, it's good to know those common fractions as decimals.
Right, so the answer's 1.8525.
You sure? That's less than the hourly rate.
I've read the calculator wrong. It should have been 18.525.
Right, that's better. You know, it's always a good idea to do a quick mental check of what you think the answer ought to be. Then you can tell if your calculator answer's way out or not. I mean, here, if Mary worked 4 hours at the normal rate, she'd get at least £10. So your answer of 1.8525 is bound to be wrong. It's a pity, though, that the answer's not realistic. I mean, the question asked how much would Mary be paid and gave you the hourly rate in pounds. So would expect the answer in pounds as well. And how can anybody be paid 0.525 of a pound?
But the question doesn't actually say anything about rounding off the answer.
Well, no, it won't. Some will and some won't. You have to use some common sense.
Right, so that should then be 18.52.
That's another common mistake, I'm afraid. Should be 18.53. Don't forget, when you're rounding off, the first digit you're getting rid of, if it's a 5 or more, you round up.
OK, Brian, make the rules for rounding off clear to us.
OK, there's 2 actually. The first one is be sensible about your whole numbers. If a question, say, wants to know how many patients a doctor sees in one day, you want a whole number as an answer.
What if it doesn't make it clear from the question?
Right, then always round off to one more significant figure than the numbers in the question. So, for example, if you're given a length of 21 centimetres, that's 2 significant figures, you'd round off to 3 significant figures.
OK, Brian, we've got as far as the exam room. Now, obviously, it's too late to do any swatting up, but it's never too late for some vital tips on where people most often go wrong.
We'd be amazed how many people misread a question and actually answer what they think they've read rather than what they have read. So always read the question carefully, and at least twice.
Twice? Is that not just wasting time?
Oh, no, not really, because it's necessary to really understand a question. If you just skim through it, you might miss some important fact. So read it carefully, at least twice, and then you can really start to sort out what maths has to be done.
Well, when it says just solve the equation, where'd you start?
I thought maths was about numbers, not shuffling letters around.
Factorisation, transposition, expansion.
Algebra might as well be double Dutch.
Algebra. Well, just the thought of it's enough to make most people want to nod off. So where do you want to begin?
At the beginning, because I never know where to start.
All right, let's have a look at this. Some of the basics here.
Algebra is the language of mathematics. 3x means 3 times x. 3 over x means 3 divided by x. X to the power 3 means x times x times x. When you know what these expressions do in an equation, you can move them around to find a solution. The simple rule is always do the same to both sides of an equation. For example, if 7x equals 9, then divide both sides by 7. That gives 7x over 7 equals 9 divided by 7. Or x equals 9 divided by 7. And x minus 15 equals 7 is the same as x equals 7 plus 15, if you add 15 to both sides. This is known as transposition. Here, multiply both sides by x. Then, take x away from both sides. So, we get 24 equals 6x. And from that, x equals 4.
Well, that's the theory. What about the practice? Brian, could you shed some light on this question?
OK.
The cost of hiring a cleaning machine is a fixed charge of C pounds with an extra charge of E pounds for each day of hire. Write down the expression for the cost of hiring this machine for 4 days.
Right, Martin's going to have a go at this one.
So, where would you start?
Well, I suppose every time you hire the machine, you'd have to pay the fixed rate of C pounds and the extra charge of E pounds for every day. So that's 4 times E.
That's right. But is that C plus E all multiplied by 4, or just the E times by 4? It'd be clearer if you wrote it down as C plus 4E.
OK, now for the next part of the question.
When the number of days hired is N, the total cost is T pounds. Write down the formula for T in terms of C, N and E.
It's just the same, isn't it? Only it's N days instead of 4. And the answer's T.
OK, so far, so good.
And C plus NE equals T.
That's right, but it will be better the other way round. That's T equals C plus NE.
Right.
We're being presented with just a bunch of letters, and mathematical terms can be awfully confusing. So what do you do to get going?
Just remember BODMAS.
Who's he?
Just something to remember. Brackets of division, multiply, addition, subtraction. Do things in that order first. Brackets first, then the ofs, then the divides, and so on.
Well, you said earlier on about the need to actually check your answers. So how do you do it on this occasion when you've got nothing to check your answer against?
Simply get your answer, substitute it into the original equation, and then see if it makes sense.
Expansion, factorisation. It's hard enough saying it, let alone doing it.
I see what you mean.
Expansion refers to the expansion of brackets, or multiplying out brackets. For example, to multiply out or expand this equation, multiply all inside the bracket by the 6 outside to give 6x plus 18. Factorization is essentially the reverse of expansion. In this formula, on the right-hand side, both terms contain x, so x can be taken out and the formula rewritten as a equals x bracket b squared plus d close bracket. Simplification is no more than finding ways to make an expression simpler. To simplify this expression, first expand both brackets and then gather all the similar terms, all the x's and all the y's, giving a much neater expression.
Here's another algebra question.
At the moment, Paul is 6 times as old as his daughter Jane. If Jane's present age is x years, write down, in terms of x, the age Paul will be in 12 years' time.
Paul's age at present is 6 times Jane's, which is 6 times x. So in 12 years' time, Paul will be 6x plus 12 years old.
Exactly right.
Here's the second part of the question.
In 12 years' time, Paul will be 3 times as old as Jane. Write down an equation for x and hence find Jane's present age.
So in 12 years, Jane will be x plus 12 years old. Paul's age will be 3 times Jane's. I've already worked out that Paul's age will be 6x plus 12 in 12 years. Now I just have to simplify the equation and expand the brackets. Combine the terms by moving terms from one side to another. Work that out. And x equals 8. So Jane was 8.
Right again. What did you have to worry about?
To know, really.
Oh, come on, Brian, there's nothing that you can do to make algebra interesting.
Hey, it's fun.
And there's no fixed way, as far as I can see, there's no fixed way of approaching a solution to any of these problems. So, what's the insider's tip?
Well, the golden rule is always do the same to both sides of the equation.
Right.
Now, I always think of it as mathematical sculpturing. You're just chipping away at both sides, moving things around until you get just what you want on its own. And always leave your answer as simply as you can. As simple as you can.
OK, Brian, when you examiners sit down to set an exam, you must have to make it fit a set pattern. So is there anything in the way an exam is put together that can help the candidate?
Yes, if you look at the number of marks per question, it's a good indication of how much work to actually show.
You're looking for 3 marks there, you'll be wanting 3 distinct things.
That's right. 1 mark could well be the method of solution, another mark for your calculator answer, and then another mark for the correct rounding off.
OK, so much for the marking system. What about the questions, the way the questions are set? Now, this question, look, it's got 1 line, but this one here, for example, has got more.
Yes, if you've only got 1 line, then you're looking for very little, if any, working out at all. But if there's more, 3 or 4 lines, then you're looking for possibly 3 or 4 stages of your working out.
Velocity, acceleration.
I never know which way the coordinates go.
Right, the new topic is graphs. So over to you lot.
Plotting points is a waste of time. Why can't we use maths to find a solution?
Well, graphs give us a visual picture of the information. Makes it easier to see trends in the data.
Let's see what we've got.
Coordinates are pairs of numbers that describe a point on a grid. The coordinates represent a position relative to the origin. That is, the point with coordinates 0, 0. The horizontal and vertical lines that go through the origin are known as axes and are often used to mark the scale of the grid or graph. The horizontal axis is the x-axis and the vertical the y-axis. Of the 2 points in a coordinate, the first is on the x-axis and the second on the y-axis. It is important to remember which way round these coordinates go when writing or reading them, particularly when constructing a graph. The acronym OUT may help. O-U-T, out and up to it. Out along the x-axis and up to the coordinate. Once all your coordinates are plotted, you can join them to form your graph.
Right, now to put it into practice.
On a quiet morning at 8 a.m, Rachel left a motorway cafe on her motorbike. At the same time, David left the same cafe in his Datsun estate car. On these axes is the graph representing Rachel's journey over the first 7 minutes. David's journey during this time is indicated in the table underneath. Plot the points from the table and join them to represent David's journey.
Right, explain to me what you're doing as you do it.
I'm reading the coordinates from the chart. Then I follow across and up from each axis and mark the point on the graph.
Fine.
Now I've finished plotting all these points, I can draw the line.
Right, but that bump on your graph doesn't look quite right. All the other points are roughly in line. I should check those coordinates if I were you.
Is that better?
That's much better. Yeah, all those points are in line now, much closer together. And you've drawn it with a nice, smooth curve. Well done.
Well, Brian, where do people tend to go wrong when they're drawing graphs?
Well, either getting the axes the wrong way around, or mainly by plotting their points. You must try to be no more than 1 millimetre out.
No more than 1 millimetre? Are you being serious?
That's right. Now, that's just half of one little square on your graph paper.
God, blimey, you have to be dead accurate then.
That's right.
You talked about the importance of actually checking your answer. How can you check your answer on something like a graph?
Well, your line should normally either be a dead straight line or a nice smooth curve.
Right, so you know if you've got something like a glitch or a very strange bump in your graph, you know something's seriously wrong.
That's right, so check your points and do that again. But also, if you know the shape that you should be getting, for example, y equals x should give you a nice straight line. Y equals x squared should give you a nice U-shaped curve.
We've looked at drawing graphs. Can't we see if we can get the information out of them?
No problem. Let's have a look at some information about that.
Reading the points on a graph is the reverse of plotting them. Simply read the values of the coordinates off their respective axes. From a distance time graph, you can read such information as the distance travelled at any time, or calculate the speed with the formula distance divided by time. The gradient is the slope of a line. In a distance time graph, the gradient represents speed. In this example, the distance of 300 meters is travelled in 10 minutes. Where the line curves and gets steeper, the speed is increasing. When the line has a gradient of 0, we are at rest. In a velocity time graph, the gradient represents the acceleration for an upward slope or deceleration for a downward slope.
This is the continuation of the question about the Datsun and the motorbike.
Calculate the gradient of the straight line representing Rachel's journey and say what this gradient represents.
I know that the gradient is the height divided by the length. So after 4 minutes on the graph, the distance will be 5.2. So 5.2 divided by 4 equals 1.3.
Good, and your method's quite clear. But what does the gradient represent?
5.2 kilometres in 4 minutes.
Well, no, it actually represents the speed, so you should say that, or give the answer in units. For example, you've got 5.2 kilometres in 4 minutes, that's about 80 kilometres per hour.
Here's the final part of the question.
At what time did David overtake Rachel?
He overtook her there at 3.5 minutes.
How do you know that?
Because it's where the two lines cross.
Right, but if you remember that far back, the question originally said that they both left at 8 a.m, so you'd be expected to give the answer as 3.5 minutes past 8.
Well, this is very useful, Brian. You got any other little gems for us?
Just a couple more hints, just to get students most marks in this topic. One is, if you've got a table to fill in from some equation, and you can't work out the equation or whatever, then always put something in the table and plot those points, because you get marks for plotting the points from your table.
Just check that. You will actually get marks for plotting points, even if the original points are wrong.
If the numbers in your table are wrong, but you plot those numbers correctly, you'll get all the marks for plotting.
So keep plugging away. Right, you promised us a couple of hints back there, I remember. What's the other one?
Well, the other one is, if you've got a distance time graph, remember it's telling you a story. Try and get into the story. The speeds that people are travelling at, the acceleration, the times they get into where, whether they're staying still or not. Get into the story.
Brilliant. You said at the beginning that you wanted to see what students could do rather than what they can't. So what happens if they get it wrong? You give them a big, fat zilch.
Well, that's why I need to see how they've got the answer. Marks lost every year because students only give an answer, no method of solution. And I can't give them any marks, even if the answer's close.
So what should be shown, Brian?
I want to see the method of solution. Basically, an indication of how they've got to their answer. Not all the long multiplication, but an indication of what they've done. If I can see the method, I can give them some marks.
Well, there's too many formulas for area, you know. Half base times height and all that.
Putting triangles inside circles.
Calculating angles. All those different shapes with silly names.
Mensuration. What on earth is that? Just the name's enough to put most people off.
Well, mensuration is all about measuring lengths, angles, area, volume from information that you're being given.
It's all very well having the formula sheets in your exams, but what do they all do?
Well, you should be familiar with what all the formula are for, even if you don't have to memorise them all.
Right, let's have a look at what some formulas do.
You should at least be familiar with these rules. The perimeter is the total distance all the way round the outside of a flat shape. The area of a rectangle is the length of the base times the height. The area of a triangle is half the base length times the vertical height. A sector, such as this, has area x divided by 360 times pi r squared. The arc AB has the length x divided by 360 times 2 pi r. The volume of a cuboid is base times length times height. The volume of a cylinder is the base area times the height, pi r squared times h. The length of the long side C of a right-angled triangle can be calculated using the formula c squared equals a squared plus b squared. Hence c is the square root of a squared plus b squared. This is known as Pythagoras' theorem. Using simple algebra, the formula can be changed round to find any of the other sides.
Well, there was a lot of formulas there. Let's see which one applies to this question.
A fleet of lorries all have to have green stripes stuck onto their sides, as in the diagram. What is the length of the stripes?
I'm not sure where to start. What should I do?
Well, it might help if you draw a simpler diagram of your own, just showing the bits that you need.
A lorry has square corners. This must be a right-angled triangle. And I can use Pythagoras. So that's 1.8 squared plus 3.8 squared. And that equals 17.68. So the length of the strip is the square root of the 17.68, which is 4.2.
Exactly right. I can give you all the available marks for that. Well done.
Well, Brian, all these formulas seem a bit complicated if you ask me. Somebody was saying there's actually a sheet you get in the exam with you with all the formulas written on it. What's the best way to use that?
Be familiar with it, because all the formulas are there that you're going to want to use in the exam, so you can pick out the right one at the right time.
So that's brilliant. You don't actually have to learn it.
No, not like we had to when I was at school.
What is the most common mistake when people try and use these formula sheets?
Using the wrong formula at the wrong time. For example, trying to use the formula for the area of a circle when they should be using the formula for the circumference of the circle. So know your formula, be familiar with them. Use your pi r squared when you should, and use your pi d when you should.
As easy as pi.
I don't understand the difference between sine, cosine and tangents.
I can get them out of the calculator, but where do they come from?
All right, let's find out.
To express the tangent, sine and cosine of an angle, we have to be able to describe the sides of a right-angled triangle. The hypotenuse is the longer side. The opposite means the side opposite the angle we are dealing with. The adjacent is the side next to the angle we're dealing with. Tangent of x equals opposite over adjacent. Sine of x equals opposite over hypotenuse. Cosine of x equals adjacent over hypotenuse. This may help you to remember. Tommy on A, ship of his, caught all herring. Tangent equals opposite over adjacent. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. To find the length y, first we must recognize that it is a sine relationship. We have the hypotenuse and the side opposite the known angle. Sine 27 degrees equals y divided by 9. Rearrange that to get y equals 9 times sine 27 degrees, which equals 4.1. Note the way the solution is set out and that the answer is rounded off.
So that is trigonometry. Let's see if we can apply it to this question.
Calculate the area of a regular octagon having a side of length 10 centimetres.
An octagon has 8 sides, so it can be split into 8 triangles like this. So if I work out the area of each triangle, I can just multiply it by 8. The area of the triangle is half the base times the height. That's an isosceles triangle, so I can use trigonometry to find the height. This angle at the top is 45 degrees, so that one is 22. That's a tangent opposite...
Hang on a minute. Half of 45 is 22.5. That's a careless mistake. You've got the answer wrong with that.
So that's opposite over adjacent. 5 divided by h equals the tangent 22.5. And that works out to height equals 5 divided by tan, 22.5. And that's 12.1. The area of the triangle is half times 10 times 12.1, which is 60.5. And the area of the octagon is 8 times 60.5, which is 484 centimetres squared.
Yeah, but you rounded off too soon. You should have used your calculator answers all the way through there to get the final answer of 483 square centimetres. You'd have lost your final mark for that answer, but your method's good, so I'd give you all the marks for that. Well done.
Well, there seems to be quite a lot of use of the calculator in trigonometry, Brian, so that makes life really easy, doesn't it?
Oh, it does. But make sure that you actually start off the exam in the right mode. You should really be in degrees mode. Normally found by pressing the mode button, then pressing button 4. But check that out on your own calculator first.
Got to be in the right mode. Now, is a calculator an absolute necessity?
Well, if you don't have one, you do stand the chance of losing quite a lot of marks.
So you better borrow one from someone else.
Well, yeah, but that has its own pitfalls.
I know what you're saying. Flat batteries.
Well, yeah, but you can easily overcome that problem by buying some new ones. Now, the main thing is if it's not your own calculator, you're not really familiar with it. You know, you don't really know where all the trig buttons are and so on. So the best thing is buy your own. Be familiar with it.
Right, what else can students do to make life easier for themselves?
Well, you might find that drawing your own diagram done quite quickly and simply might be of some use. Some diagrams might be quite complex because of the different parts to a question. So try simplifying it, making a different version for each part. It can help you to absorb the information in the question by changing it into a different form. And it helps you sort out the bits that are important.
Yeah, but you don't want to spend too long doing all that, do you?
Well, no, because if it's not asked for in the question, then there's no extra marks for doing it. But it can help you. Now, if the question does ask you to draw a diagram, then you need to be as accurate as possible.
As accurate as possible. How accurate do you want people to be?
no more than 1 millimetre or 1 degree out.
Constructions.
Bisectors.
The vertex.
I don't see how you can measure angles without using a protractor.
What are we supposed to know about using protractors, compasses and set squares?
Well, you have to be able to draw geometrical type shapes, usually as a method to find the solution to a problem.
Let's follow that up with some hard information.
Given certain information about a triangle, you should be able to draw it accurately. The three angles of a triangle add up to 180 degrees. If you know two, then you can work out the third. Given one side and two angles, you can construct the triangle. It's better to use the side that is given as the base and calculate the angles at either end of that side. Given two sides and the included angle, it's common to draw the longest side as the base. Then draw a line at one end to the right length and at the required angle, then join the other side. Given all three sides but no angles, start by drawing the longest side as the base. Use a pair of compasses to draw arcs the length of each of the other two sides. Where the two arcs cross is where the other point of the triangle lies.
As a safety precaution, a demolition contractor decides he will only knock down a chimney if he has a safety margin of 50 metres over the height of the chimney. Standing on the edge of the roof of the nearest building, he finds he is 125 metres away. Using a clinometer, the top of the chimney is at 26 degrees to the horizontal, and the clinometer 5 metres from the ground. Use a scale drawing, 10 metres to 1 centimetre, to find the height of the chimney and decide if the demolition is safe.
OK, you've done your drawing, so explain to me what's what.
These two lines represent the chimney and the man. The clinometer is 5 metres off the ground, so I've drawn it ½ a centimetre high.
OK, and how did you find the height of that triangle?
I know two of the angles. One's 26 degrees, and the chimney's upright, so that's 90 degrees. And I know that length is 125 metres, so I was able to construct that triangle.
So what's your answer?
I make that side to be 6.1 centimetres, so that's 61 metres.
Is that the height of the chimney?
Oh yes, add on the height of the clinometer to give 66 metres. 66 plus the 50 metre safety is 116, so the demolition is safe.
Good.
Brian, there must be lots of pitfalls. So where do people most often go wrong with drawings?
Drawing accurately, so use a sharp pencil and try to be no more than 1 millimetre or 1 degree out.
And that lack of accuracy actually loses marks?
Oh yeah. For example, if you're asked to draw a right angle, some people will just put the ruler down, draw it by eye. If you're asked to construct it, then get a pair of compasses. Use it accurately. Or otherwise, get a protractor and measure it.
I don't see what the difference is between drawing and constructing something. What is it you want?
Well, when you construct, I want to see how you've done it.
All right, here's something about that.
When asked to construct, you should show how you constructed the line or shape. A line bisector will cut the line AB exactly in half. Set your compasses to about 3/4 of the length of the line and draw two semicircles the same size, centred one on each end of the line. Connect the 2 points where they cross with a straight line to give the line bisector. To construct an angle bisector, set your compasses to about 2 centimetres. From the vertex at Q, draw an arc which cuts both sides of the angle. From the points where the arcs cut the lines, draw 2 more arcs across the angle. Connect the new point and the vertex with a straight line to bisect the angle. Constructing a right angle with compass and ruler is more accurate than using a set square. Place your compasses at point D and mark 2 more points the same distance either side of D. Then construct a line bisector between these 2 points. To construct a 60-degree angle at E on the line EF, set your compasses to a convenient distance. Centered on E, draw a quarter circle that crosses the line EF. Draw a new arc, centred where the first arc crossed the line EF. It should go through the point E and cross the first arc. Connect the point where the two arcs cross to the point E to construct a 60-degree angle. Since you can construct 60 and 90-degree angles and can bisect them, you can construct many more angles.
First of all, let's have a look at the question.
A mayday call is heard by 3 boats, marked on this diagram by dots, H, M and S. They can tell by the reception that the mayday call is nearer to ship M than it is to ship H, and the call is less than 3 kilometres from the ship S. Draw an accurate plan of the position of the ships using 1 centimetre to 1 kilometre and indicate all the possible positions of the mayday call.
The triangle is already drawn to scale. If the caller is nearer to M than H, I need find a halfway with a line bisector. The call was less than 3 kilometres from S, so I could draw a circle round S, radius 3 centimetres. So the ship must lie in this area here. How did I do?
Well, you got the answer correct, and your constructions are accurate too, but I'd only give you full marks if you fully labelled everything clearly.
Right, am I right, Brian? For drawings, you use anything to get the right diagram, but for constructions, you do it by constructing, funnily enough, or bisecting.
That's right. It's important to know how and when to use your drawing equipment. For example, if a question says construct, then you've got to use a pair of compasses and a ruler, not a protractor. Some students do, and they lose marks.
Now, there seems an awful lot about the weird and wonderful, wacky world of angles that seems, how shall I put this, boring.
Well, to some it does.
Well, to me it does.
Well, I can offer you no shortcuts on that, I'm afraid. Just learn as many facts as you can about the angles.
You're always talking about checking. What sort of things should you do?
Well, check that your answer's sensible. It's very easy to get the decimal point in the wrong place or to misread your calculator.
Yeah, very easy, especially when you're nervous and uptight. Brian, what do you mean by a sensible answer?
Well, say if you get an answer as £8 is the price of a car or 20 centimetres the height of a building. It's obviously wrong, so check it as you do it. And if you're not sure, then come back to it later on and see if it seems sensible.
And what if you're pretty sure you've got the wrong answer, but you can't actually spot the mistake?
Well, never cross anything out unless you know you're going to replace it. Because, generally speaking, crossed out answers are ignored, and then you get no marks.
Histogram, pictogram, pie chart.
Basically, I can't tell the difference between all different averages.
Multiplying and adding probabilities.
We've got statistics all over the place, like on television and sports, but what's that got to do with what we do?
Well, when they talk about statistics on TV, they're actually talking about real figures and data. Statistics in maths are the methods of organising and displaying that data so that it makes more sense.
All right, let's make some sense of it then.
You should be able to draw and interpret statistical pictures such as this bar chart or a pictogram. This pie chart represents 240 people who were asked to choose their favourite flavour of crisps. To find how many chose plain, we take 108 degrees and divide it by 360 degrees to find the proportion that chose plain. Then multiply by 240 to find the actual number. There are various types of average you should be familiar with. The mode is the item of data that occurs most often. The median is the item of data in the middle once all the data has been put into numerical order. The mean is what you normally think of as the average, the total of all the items of data divided by the number of items. This often needs rounding off. In this list of numbers, the mode is 3, since it occurs most often. The median is 7, since it is in the middle of the data in numerical order. The mean is 9. That is the total of all the numbers, 99 divided by the number of items, 11.
Well, going on the law of averages, we'd expect another question now. And we'd be right.
Each of 30 pupils in a class were asked how many brothers and sisters they had. The results are shown in this bar chart. First, find the number of pupils who had 2 or more brothers and sisters.
Looking at this row, there's 10 plus 6 in the next row, then 2 and then 1. So that's 10 plus 6 plus 2 plus 1, which equals 19.
That's right, and the method is clear.
Right, now the question wants you to find the total number of brothers and sisters that the 30 pupils had.
Right, so reading across the columns, that's 4 times 0 plus 7 times 1 plus 10 times 2 plus 6 times 3 plus 2 times 4 plus 1 times 5. That works out to 4 plus 7 plus 20 plus 18 plus 8 plus 5 equals 62.
Well, there's a silly mistake in there. 4 times 0 is 0, and you wrote down 4. The actual answer's 58.
And finally, calculate the mean number of brothers and sisters to 1 decimal place.
Right, so that's 58 brothers and sisters divided by 30 pupils, which equals 1.9 to 1 decimal place.
Right, well done.
And you know, Brian, I always thought an average was an average. Do students have that trouble?
That's right, they've got to know which kind of average to use and when. An exam question might just say find the average of a particular situation, and they've got to get which one of 3 kind it is. Remember, there's the mode, that's the most popular piece of data. There's the median, that's the middle piece of data once they've been put in order. And there's the mean, that's the average that most people mean when they mention average. That's when you add up all the numbers and divide by the number of numbers you've got.
Now, charts are involved here, right?
That's right.
Does drawing them throw up the same problems and difficulties as drawing and constructing geometric shapes?
That's right. Again, you've got to be accurate, no more than 1 millimetre out, or you're going to start losing marks again. So use a sharp pencil, use a ruler. Also, I want to see these fully labelled. If they don't put the labels on, they're going to lose marks.
The other part of this topic is probabilities, so what do you want to know?
Well, what exactly is it?
Chance. Whether or not an event is likely to happen.
So the real experts in probabilities are the bookies.
The probability of a simple event A is a fraction found by dividing the number of different ways event A can happen by the total number of different ways any event can happen. The probability of rolling a dice and obtaining a number greater than 4 is 2 divided by 6, or a third. The probability of cutting a pack of cards and obtaining an ace is 4 divided by 52, which is 1 over 13. The expectancy is the probability multiplied by the number of trials. If the probability of buying a dud firework is 1 in 20, then if you bought a box of 80, you would expect to find 1 divided by 20 times 80, or 4 dud ones. To consider the probability of combined events, one event followed by another independent event, you multiply their individual probabilities. A tree diagram like this can simplify everything.
And now we've got a question on that.
The probability of a bus being early is 1 in 20. The probability of a bus being late is 4 in 5. Steve uses the bus 60 times a month. How many times a month would he expect the bus to be on time?
Right, the probability of the bus not being on time is 1 in 20 plus 4 over 5, which is the same as 1 over 20 plus 16 over 20, which is 17 over 20.
Right.
So the expectancy is 17 over 20 times by 60.
No, that will give the expectancy of the number of buses not being on time. What you need first is the probability of the bus being on time, and that's 1 minus 17 over 20.
OK, so 3 over 20 times by 60, which equals 9.
That's right. Well done.
There seem to be an awful lot of fractions involved in this.
That's right, you'll not do very well at your probability unless you understand your fractions. It's worth mentioning also, don't cancel down your fractions until the very end. It'll make it easier that way. And also, remember your notation.
Oh, yes. Remember your notation. Notation. What's notation?
Oh, well, that's simply leaving your probability as either a fraction or a decimal. No ratios.
Or betting odds?
Definitely not.
There's always a lot of advice around about how to prepare for an exam, but I want to know what you suggest, Brian.
Well, revision's best started in plenty of time. Draw up a timetable and stick to it as far as possible, and generally revise in an organised way.
So how can a programme like this help?
Well, watching it won't take the place of sustained revision because we haven't covered all of every topic in the syllabus. The topics we have talked about are the ones that the students suggested because they have difficulty with them. You could use the controls on a video machine to go over the difficult bits until you understand them.
Well, I must admit it would be quite nice to rewind what a teacher says sometimes. Or even use the pause button.
Yeah, you're dead right.
To help your revision, try the Longman GCSE Maths Revise Guide. It covers the whole syllabus, with vital facts, examiners' comments to bring out key points, and lots of practice questions. Each chapter has worked examples to show how it should be done, and student answers to highlight common mistakes. Longman Revise Guides are written by examiners and are available for all major GCSE subjects.
Finally, I'd like to wish you good luck in your exam. But then again, if you've prepared properly, what does luck have to do with it?